So the question that I solved was number 30, and it reads, an 8-gram bullet is fired into a 250-gram block that is initially at rest at the edge of a table of height 1 meter. The bullet remains in the block, and after the impact, the block lands 2 meters away from the bottom of the table. Determine the initial speed of the bullet. So there's a drawing right there of it, but I'm still going to redraw the picture. And I know that I'm not going to be using grams, but instead I'm going to be using kilograms. So I'm going to just label everything as kilograms in my drawing and change all the units so that I can just start plugging into the equations. Okay, so first I'm going to draw the picture so that it's just easier for me to work. So here's the table, here is the block. Okay, so the block is 250 grams, so I'm going to make that 0.250 kilograms. And then there is the bullet. I'm gonna make the bullet really big so I can write inside of it. So that's 0.008 kilograms. And just for my sake, I'm gonna make this mass 1 and this mass 2. Okay, so, and then the table is 1 meter high. And the bullet, when they are combined and launched, they are 2 meters away from. Okay, so that's the end of the table. Okay, so this is what we are given, and we are asked to solve velocity initial of mass of the bullet, which is mass 1. So mass 1 velocity, initial velocity, that's what we're asked to find. Okay, so to do that, we have the equation mass 1 plus mass 1 initial plus mass 2 times velocity 2 initial equals mass 1 plus mass 2 times velocity final. And so we know that mass 2's velocity initial is 0 because we were given that it was at rest, so this is going to be 0. So now we have the equation mass 1 times velocity 1 initial equals mass 1 plus mass 2 times velocity final. Now when we have the equation set up, we know what mass 1 is. We're trying to find what velocity initial is of the bullet, which is mass 1. And then we know what this is, but we don't know what velocity final is. So we're going to have to find that. And the way we can do that is we know that energy is conserved. So we know that kinetic energy here equals potential energy up here. And so we can make that equal to each other. So potential energy equals kinetic energy. So potential energy is mgh, which equals 1/2 mv squared. And since it is 1/2 mv squared of kinetic energy, which is down here, we know it's the final velocity of the blocks combined. So we can make it so that we can isolate the velocity so that we can get the final velocity. So then final velocity equals 2 mgh divided by m squared. And so we can cancel that out. So then we know that final velocity is equals to 9.8 meters per second squared times 1 meter, because it's the height, divided by 1, because we canceled that out. So then if we put that into the calculator, we get that velocity final is equal to 4.4272 meters per second. So now that we have velocity final, we can plug this value into here, or into here, technically also. So I'm going to go off of this equation. So earlier here, we found out that mass 1, velocity 1 initial, and once again, this is the bullet because that's what we gave velocity initial, and mass 1 equals mass 1 plus mass 2 times velocity final. And so mass 1 is the bullet, so that's 0.008 kilograms times velocity initial equals 0.008 kilograms plus 0.250 kilograms. And then times times 4.4272 meters per second. So I ran out of space here, but this is multiplied by this. It's in the same line of equation. So like multiply, yeah. And then so if you do all of this, like you isolate the equation, you get mass 1, so then you find out that velocity 1 initial is equal to 142.7768 meters per second, which is about 143 meters per second. So that means velocity 1 initial, which is mass 1, which is also, which is the bullet's velocity initial, is 143 meters per second.